All right, so find the slant asymptote of the graph of the rational function. Okay, so we're going to slant asymptote. This is the first time we're doing this one. Let's go back to black. We're going to follow the 7-step trend to use the slant asymptote to graph the rational function, determine the symmetry of the graph of f, find the y-intercept, x-intercept, vertical asymptotes, horizontal asymptote, plot points between and beyond the x-intercepts and vertical asymptote, evaluate the function. Whoa, okay, cool. Let's just focus on the slant asymptote first. Now, the slant asymptote is actually really cool because all you really do is you just divide the numerator and you ignore you divide the numerator by the denominator and you ignore the remainder. So this is what I mean by that. So let's say we say x minus 2 goes into x squared plus x minus 2. Okay. So what we would do is we would say, well, x squared divided by x is x times x is x squared, x times negative 2 is negative 2x, and we are subtracting that. X squared cancels out with x squared. X minus negative 2x is the same as x plus 2x, which would give you, 1 plus 2, which is 3x. We bring down the negative 2, and we say 3x divided by x is 3, right? And then 3 times x is 3x, and then 3 times negative 2 is negative 6. And then we subtract, and the 3x and the 3x cancel out. And then negative 2 minus negative 6 is the same as negative 2 plus 6, which is 4, which means you have a remainder. Well, I shouldn't use that remainder sign. Let's not use the remainder sign. Which would give us plus 4. And then we just put that remainder, right? Because I can't divide 4 by x. It doesn't go in evenly at all, right? So what I would do is I would have the 4 there, and I would just put it over x minus 2. Now at this point, I'm going to ignore the remainder, and my slant asymptote is this x plus 3 there, right? So the slant asymptote right here is x plus 3, like that. You can even put that, right? So this right there, if you graph that right there, which looks like something like, oops, let's use a color that we can actually see. There we go. But if you graph it right there, that'd be where it'd cross, and then it would just kind of go through all these little points right here. Hopefully I can graph this freehand pretty well, but we'll see. So this is the vertical asymptote. I'm doing my best. All right, so okay, totally lost that one. All right, well, it's something like that. Now, obviously, that's curving downward for no reason. Okay, so let's move on to, for instance, a vertical asymptote. Okay, so vertical asymptote is I would just basically set the denominator equal to 0, which would be x minus 2 is equal to 0, plus 2, cancel, cancel, x is equal to 2. So we have a vertical asymptote at where x is equal to 2, which is right here. So it's going to be right along this line right here. This entire line is where my asymptote is. Okay, so we got that one. All right. Let's try some more. How about horizontal asymptote? Right here, right? So horizontal asymptote. Well, the numerator is a 2 power, and the denominator is a 1 power. So it's bigger on top, and it's small on the bottom, right? Smaller, bigger. Okay? And as such, there's no horizontal asymptote. Okay, so we don't even have any one of those, so we don't have to worry about that one. Okay, so we're done with this one. So there's no horizontal asymptote. Okay. Now, let's try the x and the y intercepts. X and y intercepts. Let's do a couple of those. So let's see if we want a y-intercept. That means we set x equals 0. And whenever we want x-intercept, we set y equal to 0, right? Okay, so let's see what happens if we do x is equal to 0. So f of 0 equals 0 squared plus 0 minus 2 over 0 minus 2, which gives you negative 2 over negative 2, negative 2, which gives you a 1. Okay, so that means that if x is equal to 0, y is equal to 1. Okay, so we know we're going to have a 0, 1, I'm going to use blue to represent my graph. So 0, 1 is right about there, right there. Okay. So now, let's move on to the other intercept, which is the X-intercept. So we have 0 is equal to x squared plus x minus 2 all over x minus 2. I'm going to multiply both sides by x minus 2. There's a more complicated way of doing it, but we already got the vertical asymptote out of this, so we can do this. It's okay. All right, so what that does is that gives us 0 is equal to x squared plus x minus 2. Whoop. And we set equal to 0. It's a quadratic, which is the second power right there, so we have to factor it. So we have x, because it ends in a negative, they're opposite signs. And because we're looking for two numbers we can multiply together to give you a negative 2, then if we add together, we give you a positive 1. So we know it's going to be a 1 and a 2, and since it's positive in the middle, the 2 is stronger and the 1 is weaker. Okay, so what we do is we say x plus 2 is equal to 0, and we say x minus 1 is equal to 0, which means x is equal to negative 2, and we have x is equal to 1. So we just flip the sign, basically, right? Okay, so now I'm going to plot those points. So well, let me finish writing this out, because technically you should always write these as ordered pairs for the intercepts, right? Intercepts are ordered pairs, so this is going to be, those are my 2 points. Okay, so I'm going to plot those points. Okay, so one of them is at negative 2, 0, which is right there. And the other one is 1, 0, which is right there. Okay, and you can already kind of see how this is going to be a curving thing. It's going to go right along this red line that's vertical, and it's going to go right along the red line that is slanted. Okay, so we already had, so we already have, now we have our intercept, x-intercept, and y-intercept. Now, I don't know if I'm going to have enough room to do the symmetries, but whenever I'm trying to find the symmetries, first I can do it up here in the upper right corner. So let's say we wanted to do the y-axis symmetry, right? So y-axis means you plug in a negative x, right? So f of negative x. And f of negative x is negative x squared plus negative x minus 2 all over negative x minus 2. And when we simplify it, we end up with x squared minus x minus 2 over negative x minus 2. And as we see, we did not get back the original. The x has an opposite sign right here. Let me circle what I'm talking about. So you can see the x has an opposite sign right there. And you can see the one at the bottom has an opposite sign. Even if we multiply both sides by a negative, we're not going to get back the original. So it looks like it does not, in fact, have y-axis symmetry. So that's not something, right? So what about x-axis? Okay, so what about x-axis? It's not going to have any symmetries, by the way. You can kind of already tell how it doesn't look like there's any way around these the slant asymptote and the vertical asymptote to have any symmetry. So I'm doing a little bit of a not as good a job as I could, but this just is obviously not going to work. I'm just proving that it's not going to work out at this point. Okay, so we have negative y is equal to, we have x squared plus x minus 2 all over x minus 2. There's no way, even if I flip the signs, right, so I could make that a positive y, but then I have to flip all the signs over here, and I end up with the same problem. There's no way I can get this to match the original, so we couldn't do y-axis symmetry, and we can't do x-axis symmetry. So they're both, no, oop, that little different color to make sure it's obvious. And then of course we have origin symmetry. So origin symmetry, just proving it, right? I'm going to plug in a negative x, and I'm going to plug in a negative y. Okay, fair enough. So I say negative y is equal to, and we already plugged the negative in for the x, so I'm just going to use that. The result of that, I'm running out of room, so I'm just going to use it. So we have x squared minus x minus 2 all over negative x minus 2, and that's not the original. You can try to flip all the signs on both sides by multiplying both sides by a negative 1. You're still not going to get back the original one. It's just a mess. You don't get back the original. So there's no way to really get this to match. So this is another no. This one does not, in fact, have origin symmetry. So it has none of these symmetries. Okay. So I kind of saved that for the last because it just isn't. It wasn't going to work out. So no symmetries. Okay. So we can actually get a few more points, even though it's kind of obvious where they are. So if we want to get more points, we could. But at this point, it's really not necessary because we know it's going to hug this. It's going to hug this slant asymptote, and it's going to curve, and then it's going to go over here, and then it's going to hug this vertical asymptote. Oops, just like that. So we know it's going to shoot off in this direction along there and there. So we know that's what it's going to look like as if we graph the function. Make sure I answer everything. It says plot points between and beyond the x-intercepts and the vertical asymptote. If you do plug in some points in between the vertical and the horizontal one over here at the top, you are able to find some more points. So for instance, whenever you plug in a 3, it spits out a 10, which means that there is another point. All right, so when you get to 3, there's a 10, which is right there at the edge. And then whenever you plug in a 4, you get a 9. So whenever you plug in a 4, right, which is right there, you get a 9, which is right here. The graph isn't quite big enough to make this obvious what's happening here, but then when you have 5, we have 9 and 1/3. So when you have a 5, you have a 9 and 1/3. So it's just barely right about there. It's not a nice even number, but it'll work. And what happens is you can see you have this go over here, and then this is going to go up there. Okay, and that kind of completes your graph. So we wanted to pick, we already had some points on the left side of the vertical asymptote, so I picked 3 points on the right side of the vertical asymptote. And that's what I got.